Now let's take a look at number 5. And the number 5 is to help you. So I'm gonna do number 5, which will help you do the number 6, which are very similar, right? So again, I copied that here, but I will just show you how I would attempt number 5. This is the equation that we want to solve. We want to solve to accurate to 10 to the negative 2. Using the thing is we need to use fixed point iteration method. So we need to somehow convert this roots finding problem to fixed point finding problem. Certainly there are many ways to do that, and in the near future we actually will learn how to find very fast fixed point method. Okay, but for now, at this point in time, you probably just trial and error. So I'm gonna just begin my luck to rewrite this roots finding problem into a fixed point problem. In other words, write it into x equals g of x, and we need to find this g of x. So one quick way to do is maybe leave this x to the fourth on one side and move all the other terms to other side, right? And then take the fourth root. So this is what I have, 3x squared plus 3, and then take the square fourth root, all which is the same as saying this guy, right? Raised to power 1/4. So this is what I would type in my, this is my g, and then this is what I would type into my my program, the fixed point program. I mean, this is the g of the function g that we found. I typed that in my program, and let me run it. So you see that it works, right? After 8 iterations, I've got my p. Actually, I'm sorry that I used 10 to the negative 3. I'm supposed to use 10 to the negative 4. I mean negative 2 in this problem. So my tolerance will be this guy. So I'm gonna rerun that again, and I just need 6 steps to get to my answer. So my answer is gonna be, what is it? 1.9433169. Okay, so this is what I have, and I did use the initial value indicated by the problem, p0 equals 1. Now some of you may ask, is this answer unique? No, it certainly is not unique. It really depends on what g of x you use, right? So in this particular problem, you could certainly rewrite this roots finding problem into another fixed point problem like what I'm doing here, and then I will divide both sides by 3. So I will have x to the fourth minus 3 over 3 is equal to my x squared, and then x is square root of x to the fourth minus 3 over 3, and I should type this in if I prefer to do it that way. So I will type that in my Mathematica. Okay, so this is the new g of x that we just derived, and I typed that in my g of x in Mathematica in the fixed point iteration program that I wrote, and then I want to run it and continue to run it. This time, do you see that? Take a look at those numbers. They are actually complex numbers. They are not real roots. So in this case, this particular one will not work, right? So in this case, you don't provide me this answer. You're gonna continue to try until you get the one that's working like this one, right? So this is the explanation for number 5. Again, you have to try to find the g of x that will produce the a sequence of solutions that are convergent to the real fixed point.